Hello, and welcome to another Predictive Fleet Technologies video. Today, we're going to show you how to get an engine polygraph report. Meet Applications Architect James Mentally, who will demonstrate how to set up the engine polygraph's instruments in order to collect data.
I'm going to be working with my personal auto. It's a 2003. First we have to open the hood in order to get at the oil dipstick tube. I always like to wipe it off before and after I insert the stick into the tube. Oil level looks good, and so I'll get the sensor. So here's the first look sensor, and it is a threaded sensor, so that I can take this nose and thread it on, put it into the dipstick tube, and it fits quite snugly there. We have different adapters for different styles and dimensions of dipstick tubes. Sometimes you have to use the oil filler tube depending on the particulars of the engine you're working with. And here's the BNC cable that we attach. And I like to connect the BNC cable to channel B. Next we will get the picoscope out. And what we have here is a 4-channel. And I'll put the crankcase on channel B. And I'm going to set this on the driver's side of the car, and then hook the BNC cable to channel B, as I mentioned. So now I take the other end of the BNC cable, and I like to put the BNC cable along a path so that it's not likely to get caught into any of the moving parts of the engine when it's running. Now I'm attaching the crankcase sensor to the picoscope, channel B. I'm going to set this in here on the seat, and now I'll get the exhaust sensor. We use first of all the clamp with a silicone rubber hose. I'm going to thread another sensor into the end of the exhaust collector, and then I'll insert that into the tailpipe, and then use the other BNC cable to connect it to channel A. So here's that exhaust capture hose, and I thread in the second first look sensor, and now it's ready to insert into the tailpipe, and so that's what we'll do next. So here's the tailpipe. I insert the hose in and put the clamp on the tailpipe, and then at the first look coax connector here we'll connect the BNC cable and the other end to channel A. So now I've got the exhaust connected to channel A. I'm going to set this down on the seat, and I like to put the cable wires over the mirror here so that there's a little less chance of someone accidentally opening and closing the door over the cables. So here I'll start up the engine polygraph reader application, and it asks if I really want to do this, and the answer is yes. I have to put in my password, and now I have to fill in the information about this particular vehicle and the other information I need in terms of testing conditions and what I want done. Before I proceed, though, I'm going to shut this down while I type in that information. I like to use the license plate for the vehicle ID, but other than that, things are pretty standard, using pull-down menus to make selections. In a few cases, we have to type in a number. So I'm going to do that and then come back.
Here we have the engine polygraph reader. The first section verifies the user as well as the company we are working for, along with the language and the version of the software. Next, we have suggestions on how to proceed. Below this screen, we have the identity of the owner, what vehicle is being worked on, whether this vehicle is part of a fleet or not. For this, the owner would be the fleet name, and the vehicle would be verified on the Engine Fleet Management subscriber list to coordinate and connect the data. Below that, we have engine manufacturer, and next to that, you will have a drop-down for the engine model. This will be sorted from the lowest displacement to the largest. Then it will talk to the database and will give you the engine configuration and displacement according to what is entered here. Next, you indicate where and when you are performing the test, a few details on the engine, the odometer, and the engine temp. Below that, are you running idle? Are you running load, which is approximately 1500 RPM, or doing a cold crank with the starter motor? After that, you provide the RPM and where you got the data. Usually this is an estimate. Next, describe which sensors are connected where on the vehicle and to which channel they are connected to. Below this, you identify what you are doing here. What is the purpose of this test? Is it a one-off or a single test? Is it a before or after? Indicate that here. If you have a trigger channel with a sensor to identify an ignition point, which cylinder is being monitored? Next, we select what report we want, an assessment or a diagnostic. After this, where do you want the report to be sent to? Enter the email address you wish to use here. Finally, press the next button, and a message will display for you to bring the engine up to speed, whether it be idle or load. Then, on the side of the screen, the start button will appear. And upon bringing your engine to the appropriate speed, select start and the process of the data collection will begin. Finally, after everything is done, the complete button will turn green and you are set to start the next signature that you wish to work on.
So now I'm getting into the car. It's already running and all warmed up. I plugged the picoscope into the laptop. Since I've already keyed the data in on the screen that we just discussed, I quickly review it. When I hit next, the picoscope will start up and the program will determine the duration for the signature and the frequency for the readings from the sensors. And it'll send those parameters to the picoscope. The upper window lists steps to be completed for a final check. Also, now the system is checking all of the BNC connectors to make sure the sensors are connected as identified. We hit continue and the message says to accelerate the engine to the specified RPM. But since we want idle, we're ready now to continue. The red start button turns the letters white and it has a red light below, so it's ready to go. I push the start button. The program checks all sensor connectors and the input signals, checks if the RPM is steady and are reasonable patterns coming in. Finally, after the correct time for a good signature, less than 2 seconds, it will prepare the files and upload the files to our servers. Then the light will turn green and we're done. So we can hit continue to go on to the next signature from this engine, or we can go to another vehicle. Those are the steps to collect the engine signature and send the data to the Engine Angel sensors. They are now producing the report. It should be done in a few minutes. At this point, I'm going to shut it down so we can go inside and look at the output. Actually, before I go inside, I'm going to talk a little bit about taking down the equipment. So I'm first pulling the exhaust sensor out of the tailpipe, and what I want to do is take the sensor off the hose, since there can be moisture trapped in that the exhaust gases that are in the hose, and want to keep the piezoelectric sensor as dry as possible. So now I'm just unthreading that first look sensor here, rather than pulling it out like you might have with a knob sensor. I blow out on the hose using the sensor end to blow in rather than the dirty carbon end that was sticking up in the tailpipe. And so I'm going to stop here. And here I take the sensor out of the dipstick tube and remove the BNC cable and wipe off the dipstick itself and reinstall it. So at this point we put away the picoscope and wrap up all the cables and put them away, and then we'll go in and look at the result.
This is the first page of the diagnostic report that is returned after running an engine polygraph test. We did request that the report is a diagnostic instead of the assessment report. Word of note here, everything in the assessment report will be displayed in the diagnostic report, but the diagnostic report will deliver more details of your test. The assessment section of the report has two pieces. The top portion describes the scores for this engine in 6 categories, 3 of them being the upper engine and 3 being the lower engine. The report uses a color-coded and number scale, where 1 is green and means very good or excellent, and 10 is red and means terrible. The section below describes the concept of what is being measured. We won't go into it here, but we do go into further detail in another one of our videos. This page of the diagnostic report will list out any abnormal observations along with possible causes according to the rules we've derived from experience. We also provide a confidence factor that those causes would produce these observations, and finally some possible solutions to the causes. Here, we have 2 possible causes that are potentially related. The second one gives us an additional question to ask ourselves. Here, we're asked if we see any black smoke on an open throttle. If yes, then we are going to consider more the bottom cause. If not, then we are going to be looking more at the first potential cause of the issues. To quickly go through the report, there's a big vacuum pull in the crankcase for one of the cylinders. What is a likely cause is that the compression rings are caked into one position by carbon deposits, so that as the piston pushes out the exhaust, that particular position is likely frozen, so now when the piston goes down for the intake stroke, there's too much room for the vapors in the case to get sucked up into the cylinder, and this would likely cause a misfire, and a more obvious outcome is the big vacuum dip, since the crankcase vapors were sucked into the cylinder. Now, the suggestions will tell you that you might use a carbon cleaner, a fuel additive, or hydrogen treatment to alleviate the issue. The second possible cause is that the cylinder walls could have some major scoring, allowing air flow alongside the piston. If that is the case, you will see some blown down into the crankcase upon the power stroke. So the question is asked, if you give it a wide open throttle, do you see black smoke? If the answer is yes, then it's more likely that you see the second cause of the issue as opposed to the first. Now here we have the model graphic that was taken during the idle test. This graph is being measured in milliseconds. The system determined to start looking for an engine cycle in this waveform, from A, being cylinder A, down to F, in firing order, in the exhaust. Down in the crankcase, we can see that there is a huge vacuum pull starting in A, then it moves through the cycle, and we see the pattern begin again at A. The upper engine doesn't look too bad here, but what we do see is that F has a good spike, and A is in pretty good size. Some pretty poor combustion is shown in the third cylinder of the firing order, so we have a misfire, and it's flashing a little bit later in the exhaust system, maybe making it appear that the cylinder has an awful lot of gas, the spike that is shown in A. That's about all we're going to discuss in regards to this model. For more information, you can find us at predictivefleettechnologies.com. If you want to contact us, feel free to do so at support@predictivefleettechnologies.com. Remember, be on the lookout for more videos in our series about engine polygraph. We hope you all found this useful and would love to hear from you for any help.